Welcome everyone. Welcome back for all of you who have already seen some awesome presentations this week. It's the 7th edition of Programmer Seek here at Cognizant Softvision, and we are thrilled to have you this year. Our aim was to go beyond. Today is day 5, and today is all about big data and analytics, AI, machine learning. So make sure throughout the day you take a look at some awesome presentation in these topics. For this session, we will go over SQL Server transactional replication, initialize subscription from backup. So make sure to take your questions and pop them up in the chat module. The presenter is a senior database engineer and a team lead for one of our teams. He has more than 15 years experience working with SQL Server. He comes from an administration and performance tuning background. Without further ado, I present to you the grumpy himself, Bogdan Toma. Bogdan, take it away.
Thank you, Ioan, for the introduction. Hello, everybody. Today, I have the pleasure of talking about SQL Server transactional replication initialization. First, let's see what is replication all about. Replication means to have the same data in more than one place. Why do we need the same data in more than one place, you may ask? There can be different reasons for this. The main one I came across are offload work from the main server. For example, move the reporting part of your application to another machine. And in some cases, it can be used as a disaster recovery. A common architecture for replication will look like this. We will have two sides, one for the publisher and one for the subscriber. On the publisher side, we will have the database that we want to publish, the articles that we want to replicate, and the distributor. On the subscriber side, we will have the replicated database with the replicated articles. When we speak about articles, we refer to tables, stored procedure, functions, objects that you want to move to the other side. You may see here that we also involve the log in this diagram. We all know that we have actions on the database, and those actions need to be recorded somewhere before they get to the tables, stored procedures, and functions. That place is the log file. The one responsible for reading the log file is the log reader agent. His mission is to parse the log and identify the articles that are marked for replication and take the transactions that happened on those articles and move them to the distribution database. The distributor or the distribution database role is to match the publisher to the subscriber. In this diagram, we have a publisher and a subscriber, but we can have different architectures where we have multiple publishers and multiple subscribers. Multiple publisher can go to a single subscriber, or a single publisher can go to multiple subscribers. The distribution database role is to make that connection. We can see also here the distribution agent. The role of the distribution agent is to replicate the data onto the subscriber. So for example, if we have an action of delete on a table, user comes and makes a row delete on a table, the row delete is recorded in the log file of the database. The log reader comes, reads the log file, identifies the delete action. It then checks if the article is mapped for replication. If it's not mapped, it just skips it. If it's mapped for replication, it goes and takes the delete action and all the details from the transaction and sends it to the distribution database. The distribution database then, based on the information from the log reader, knows which subscriber must be populated with this data. It sends the data to the distribution agent, which will replicate it on the subscriber side. Now, the subscriber side can be used, for example, for reporting, while the main server takes care of the day-to-day business of your application. We saw a small description of how it works. Now we must see how replication is split. So we have three main replication versions. We can have different smaller derivation from these three main replication, but most of them follow the same architecture. So we have the transactional replication that is continuously moving the change to the subscriber in an ongoing process, active all the time. We have the snapshot replication, which is much simpler. From time to time, new point in time version of the data is moved, so it is not always up to date. We then have the merge replication. This one, it's a little bit more complicated. For merge replication, data moves both ways. If in the other two types of replication, the data flows from publisher to subscriber, here, the subscriber can update the publication as well. So based on this behavior, transactional replication is typically used in a server-to-server scenario that require high throughput. Snapshot replication is used when it is acceptable to have copies of data that are out of sync with respect to the publisher for a period of time. Merge replication is primarily designed for mobile application or distributed server application that have possible data conflicts. Common scenarios include exchanging data with mobile users. So you can see here that the transactional replication sends the data to the subscriber in near real time. For the snapshot replication, the data is only moved at one point in time, and then subsequent transactions are not moved. Everything that happens after the initial initialization is not moved until we reinitialize the snapshot. For merge replication, subscriber can also update the publisher. So it's a two-way action. If we go back to the diagram, we can see that this diagram is for the transactional replication because we have the continuous log reader agent action that will send the data to the subscriber. If it was for the snapshot, the part of the log reader will not work. It is not needed. A snapshot replication only takes the data from the publisher, it moves it with the distributor and snapshot agent to the subscriber side, and it stops. All other actions that happen afterwards are not monitored. And if you want to have the subscription database synchronized again, a new snapshot must be created. For the merge replication, this distributor agent will be called merge agent, and it will have both ways flow. The subscriber will also be updated and can update the publisher. The distributor role will be more complicated. It will have to also take care of the conflicts. If the same row is updated on the publisher and on the subscriber, the distributor will decide which value is the latest one. You may have noticed here that all of the replication contain the snapshot word. Why is this? Because by default, the start of the replication contains the snapshot. In order to make a replication, you need first to move the initial data, initial state of the database. And this is done using the snapshot. We saw a short presentation of the main types of the replication and how they work. Now let's see how we start the replication process. As we saw, replication consists of two parts. First, we need to initialize it, and then we need to keep it in sync. By default, all types of replication use a snapshot to initialize. In order to start the replication, snapshot of the published articles is taken. And in the wizard, you will encounter a step asking you where to set up the snapshot. You can use a default folder or create your own folder where to store the initial data. You have the ability to run additional scripts if needed. You can see here on the publication properties under the snapshot option, we have the default location of the snapshot, or you can define your custom folder. Please take a note to the compressed snapshot file option here. It is only for the custom folder. You cannot use this option when we have the default folder. Here you have the additional snapshot scripts that needs to be executed in case you have logic, additional logic. Now, for small databases where objects that are replicated, especially tables, are small, the snapshot is quick and performance is not impacted too much. But on big databases, snapshot can take long time to generate. It will put stress on the publisher server, on the disk, on the CPU, and on the network. It may cause blockings and delays in other transactions that are running, depending on the options that you choose. SQL Server provides a way to see the state of your replication. It is called Replication Monitor. You can see here some types of error that you may encounter. While permission and security can be fixed relatively easy, the fact that snapshot will be big and take a lot of time and space to be created will be harder to fix. So access, permission, all these kinds of retries, errors, you can figure out the solution. But if you get this error that the process is running and it's waiting for a response from the server, it's harder to fix. It's harder to make a snapshot faster. This is what you may see during a big snapshot creation and initialization. You get a single row message where it says that snapshot is not yet available, no other details. You may get additional information saying that the snapshot is not fully generated, or there is a problem with the log reader agent. You may also see in the snapshot agent that for big table, the agent is hanging. You can also see that the snapshot folder is getting big. How the snapshot is created? Snapshot agent goes, identifies the tables that are part of the replication, and then takes the data and all the options of the table and dumps them in a file on the disk. So it uses BCP to move the data on the disk, and from there it will be moved to the replicating server. This takes time and resources. What can we do to make the initialization of the snapshot faster? You have the option to compress the snapshot in order to reduce its size, but this option comes with limitation. If you remember the compress backup option on the custom folder, this is only for the time where you move from the default folder to a custom folder. Compression has limitation, meaning additional time to run the compression has noticeable impact on the CPU. It is limited by the operating system to files no larger than 2 gigabytes. So if a table is bigger than 2 gigabytes, the table is split into files of 2 gigabytes, and then it is compressed. If a data file larger than 2 gigabytes is created, the process will fail when it tries to compress it. The snapshot process is pretty good about breaking large tables up into files of 2 gigabytes or smaller. But every once in a while, you will hit one that is slightly larger and it fails. You have to take into consideration also the network fails. If you have an unreliable network, compressed snapshot cannot be resumed. You need to start over. We created the snapshot, but now we need to move that snapshot to the subscription part, to the subscriber database. Once the snapshot is created and is big, you may encounter this kind of alert message saying you have latency, performance is critical, and you may see that the snapshot agent is trying to bulk insert this time the files into the subscription database. We talked until now about the snapshot option of the initialization. We saw how it works and what problems it may encounter. We have another option besides snapshot in order to make the initialization: backup. We can use backup to move the initial data to the subscriber database. Of course, this is not an option for the snapshot replication, because there everything gets moved and we don't have anything to follow up. You just take a snapshot of the published database and move it all over. But it can be an alternative for the transactional replication. So if you have a big database that you need to move to the subscriber and then monitor all the actions that happens on the publisher, and you do not want to put stress on the publisher server by moving the whole logic and whole data while you implement the replication, you may use this option of initialize from backup. We will see now a small example of how we can create this replication using the backup initialization. For this, we will use a database. I called it BigDB. This database has a couple of tables, and it has one store procedure. Tables have primary key. This is a mandatory request for the replication, for the transactional replication, in order to identify the rows that are being modified. Now, in order to use the backup for initialization, we must create a backup. Usually, environments may have maintenance plan for backups already in place. It is always a good idea to have backups in case disaster happens, something wrong happens with your server, and you lose access to your server or database. In our case, we don't have a backup, so we will do it now. While the backup is running, let's take a look on the tables. You can see that we have one table that is bigger, the other are smaller. For the tables to work, you need primary key. Don't forget this. You won't be able to create a replication, a transactional replication, if you don't have a primary key. If the process is unable to identify the row uniquely, it will not work. Once the backup is created, we can start our replication. So what we need to do first, we need to restore the subscription database. This script will create the subscription database and will also create the publication. We have here some variables, the definition of the publisher server, the definition of the subscriber server. In our case, it's the same server, but it can be different servers. We will use our big database as the publisher. We have the big database backup that we created in the previous step, and we will use this path for the subscription database. While restoring the database, please notice this option, no recovery. The database will be restored, but will not be accessible. You will see why it is necessary to have this no recovery option a little bit further down the presentation. We also validate that our database is being published. If it's not published, we will move the value to true. We will mark this database as a published database, part of a replication. This part is only for some general description for the publication in order to know which database is involved, what we want to replicate. In case the replication exists, we will drop the articles and recreate them. This part adds the publication. This is where we actually start the first step of the replication. You have to take notice of the allow initialization from backup parameter that it's set to true. So our replication will be initialized from backup. We will not use a snapshot. To make sure that no snapshot will be created, I commented the add snapshot option. So the snapshot will not be created. Down here, we have the articles that we want to replicate. Remember, they are the same articles that we have here. We have the tables and the store procedure. Now, you may notice that I've commented PostType Table. I don't want this table to be replicated. The actions that happen on the publisher for this table, I want to stay only on the publisher side and not be replicated on the subscriber side. If we go and look over the options of adding the articles, we will look at schema option. These values keep what we want to move. We will show in the designer how this value is changing. We have the identity management option. If we have identities on the tables, we don't want them to be recreated on the subscriber side. We want the replication mechanism to take care of the identity. The destination tables, in our case, we use the backup, so we need the same name for the destination tables. And then you see for the drop index store procedures that we do not have any more parameters. This is because the tables have the action of insert, delete, or update, and they need to have store procedure automatically created to handle those actions. Procedures don't need to have this. So let's create now our publication. You see the database being restored. The database is restored, but we cannot access it. The database is not accessible. If we look on the output, we see that a job is created. This is the log reader agent job. Starting from this point, every action that happens on the big database will be monitored by this job. And if they are related to articles from the replication, they will be moved to the distributor database. But we don't have a subscription yet. We only have a publication. You can see here the job that it's running. We can see the publication, but we do not have a subscription yet. We can also see that the view snapshot agent does not exist. We have no snapshot agent. While we restore the database, some action may happen on the big database. It can be a live environment, user can use it. Changes can happen on the big database. So we will use big database and see how many rows we have in the vote types table. We can see that we have 15 rows. We'll insert one row. And now the table has 16 rows. The last one is something changed after the backup restore. If you remember, we had the PostType table that we do not want to replicate. And we will do the same actions here. We want to see that these actions are not replicated. Something changed after. If we go and see the log reader agent status, you see that one transaction and one command was delivered. So only the action for the vote type was identified by the log reader agent as being on a table that is replicated, and it was moved to the distribution database. Okay, so now we have the publisher, we have the subscription database restore, but we cannot access it. The replication is not working. What we need to do is to enable the replication. But how will subscription database know to take information from the big database? How the distributor will know from what point in time to replicate the data to the subscriber? You remember that this log reader job was created when the publication was first created. So starting from that point, all the actions that happen in a big database are recorded. So we need to move that point also to the subscriber database. For this, we will use a differential backup. We will restore this differential backup on the subscriber database, and then we will initialize the subscription. We will use initialize with backup option, and we will use our differential backup in order to start the replication process. You see the backup, the differential backup being done, the differential backup being restored, and then the job, a new job being created. Now we have the distributor job running. The distributor agent job is running. We can see the database being active. We can see the objects being replicated. But we see the PostType table. Why is this PostType table here? We didn't add it in the replication. This is because we use the backup. When we try to use the backup, everything that we have in the publisher will be moved to the subscription database. But actions that happen after the restore of the backups will no longer be moved to the post types. If we go to the store procedure, we'll see more store procedure. We have the original drop indexes, but we also have the store procedures that are for the delete action, insert action, and update action. If we try and open one of these, we can see the logic of the delete store procedure. You see that it's working based on ID, on the primary key of the table. If you have, for example, an action that deletes 10 rows on big database, this will be replicated in 10 calls to this store procedure, each and every one per ID. Now you can also see a validation part of the code where in case it does not find the delete row, it will raise an error. This is why for the subscription part, you must be aware that any action that you do may impact the replication process. So in case you need to have additional logic on the subscriber database, you must make sure that logic is not interfering with the replication process. If it's interfering with the replication process, you can change the code from this store procedure to match your request. But you need to remember that these store procedures are recreated each time you reinitialize the replication. So you have the ability to add your own code, but you must be careful each reinitialization to add that code again. We see that the objects are here, but let's see if we have the data. Big database, the original one, the publication has 16 rows. Something changed after the backup. So let's see if we have this in our replication as well. And we have it. We have 16 rows also here. We will check also the post type. We had 9 rows in the original one. And here, let's see what we have. Oh, we have 9 rows. Why? You remember that we initialize it using the differential backup. So the action happened because we restored the differential backup, because we needed to bring this moment of the creation of the publication also into the subscriber database. So before, everything that it was before initialization will be brought into the subscription database. We need now to see if the replication is working. So for this, we will try to insert rows into the table that we do not monitor. We do not want it to be in the replication, and in the table that we want to have it in the replication. So let's insert one row into the table that we don't want to replicate. We see that we have now 10 rows in the publisher database. And now let's insert one also in the one that we monitor. We have 17. Validate replication is working. If we move to the subscription part, we see only 9 rows on the table that we do not monitor, because now the replication is working, and the action for this table is not being replicated. If we go to the vote types, we will see 17 rows. Validate replication is working. Also, if we go, we see the subscription created, and we see that one transaction with one command was delivered. So only for the vote types, the change was moved to our subscription database. We still have the PostType table in the subscriber database. It contains all data. It will not be updated with the new information. If you consider that objects that came with the full backup are sensitive, and users that will use the replication database, the subscription database, which should not access those tables, you can just remove them. Backup initialization will not work in all scenarios. It has limitations. As you saw, all objects are moved initially, and if sensitive information exists, you must take action after the initialization occurred. Based on each scenario you encounter, you can choose what is the best approach. What is important to know is that transactional replication can be initialized also from backup. You do not have to wait for the snapshot. Snapshot initialization is used, it's very useful for small databases. And it's the default and the simplest way to do it. You can go in the wizard and just initialize it. Also, when you have multiple publisher and single subscriber, you cannot use the backup initialization. You cannot restore more databases on a single database. But backup initialization is most beneficial with very large databases when the initial move of the data is the biggest impactor. We need to move a lot of data first time, and then the transactions will be monitored by the replication mechanism. You don't want to wait, or you don't want to put stress on the publisher server. You may restore the replication database, the subscription database, before, and just use it as the source of the initialization. Another thing that you should see here on the properties of the publication, we have the articles. You see here, the post type is not part of the replication. We do not use this as part of the replication. If we select the properties of this table, you remember the schema option. All these parameters will change the value of the schema option. So in our case, we only copy the cluster index. We don't copy the non-cluster index. If you change this filter, this option, the schema option will be changed. You have the ability to move at parts of the options of a table that you want or store procedure. We will now move to the Q&A section of this presentation.
Well, Bogdan, you have been really intuitive in the way you presented, and I believe everyone can replicate the demo that you just made. No questions were asked, so thank you very much for the presentation.
Thank you for attending this presentation. I hope you found the subject interesting. And if you encounter a transactional replication snapshot that takes long time, you may explore the backup initialization approach. Please don't forget to scan the QR code and fill the feedback form. Thank you again.